Of late, I have been working on something exciting. Fundamentally, it's an IoT project wherein you can literally control any of the electrical home appliances just with a tap of your phone or through your voice commands as well. And an interesting thing about this is you can literally do this from anywhere else, which necessarily means that you need not be right at your home to do this. Or you need not be within the proximity of the device or the appliance in order to do this. You can also use your voice commands as well, as I mentioned. Further, you can also use the Google Home Assistant that's built in your phone, or you can also go for the Google Home devices which are commercially available these days as smart speakers, or you can also use your headphones as well if it has got a built-in voice assistant that can respond to your commands like any other voice assistant. I would demonstrate all of this in a while. I think it's pretty difficult to handle it this way, so I would rather ask someone else to record it for me. Meanwhile, I would pause this for a minute or two and set this stuff up. For this project, I'll be using ESP8266, which is a Node MCU hardware, and this is the Google Home Assistant, which we can ask it to control or give some voice commands to it. And this is the single volt, like single channel relay, which I'll be using to control the electrical appliances. And this is Bose Quiet Comfort 35 headsets, which has got a very good noise cancellation feature, and it also has got a very good like built-in home assistant as well, through which we can instruct it to do some tasks. Of course, in fact, it's been one of the best headsets that I've ever used. So, so now if I would just go ahead and set up Blink libraries. For that, I have to connect my Node MCU to the PC. Uh, Okay, initially you have to set up Blink libraries, and then open up for that you have to open up the Arduino IDE, and then make sure that appropriate COM port is enumerated, which means that now the connection or the communication channel has been established between your computer and the board. Then now I will go to the tools option in the Arduino IDE and make sure that Node MCU is chosen. Then browse the Blink libraries that were set up, and make sure that the appropriate Wi-Fi settings are reflected in it. And so after that, you will have to fill up your auth code and Wi-Fi username and password, so that this device is always up and connected to your home Wi-Fi. And the auth token, or the authentication token, is something that's sent to your email when you first register and create the project in the Blink app. I have already done all this in my code. Now I'm just flashing that code onto my hardware. Here is the app called Blink app, which you can use it on your Android phones or iOS devices as well. So I have already got it installed. Let me bring this up. And so here is the app. So this has got a very good GUI as well. It also supports numerous varieties of hardware like Arduino, ESP8266, and some of the Intel versions of boards like Intel Edison, and TI boards like TIVA, Launchpad, Particle Photon core, and like some STM32 boards as well. So and the list goes on and on. Mm, I don't want to disturb any configurations that I've already done, so I'll just go back. So this is a simple button that I've created. This just has got only one button because I'll be controlling only one device for today in this video, but you can tweak it the way you want, and it can be customized in several different ways. With all the GUI objects available, you can also add different options from this list that I've brought up. I would say this is something worth exploring. So now I would go ahead and make some connections to the hardware. Here we need three female to female jumper cables, which I have connected as shown here. Um, so I have connected one of the jumper cables to ESP8266, the pin of D3, which will go on the relay. You can choose any pin of your choice, like D4, D5, etc. It's not mandatory that you only need to go for D3. I'm using this pin because I have configured my app to that. Next, give VCC and ground. I'll choose these two pins, and again, that's of your choice. You just have to supply a 3 volt, and then for VCC, and then a corresponding ground. We'll start testing the project using our app initially. So for that I have to make some more further connections. So here they are. I would take my relay out. So this is my single channel relay, and as I mentioned, this is the ESP board that we are using. As I mentioned, like the D3 on it would go to the relay. So I take the D3 pin from this board and then connect it to the signal pin on the relay, and as usual our VCC or the 3 volt would go to the VCC on the relay, and then the ground pin from this would go on to the negative terminal or the ground on the relay. So these are the connections between your ESP8266 and the relay. Now some more connections are left to be done on the relay to the mains. So this is the light, by the way, that I'm trying to control today. This is the wire which should go in the mains. So I would interface this wire between the relay and the mains. So this is the wire that I'll be using, and this is the wire that's coming from the light. This would go to the relay, and then this would go from relay to the main power supply. Let me make some connections. So the neutral pin of the main power supply, I'll be connecting directly to the neutral of my light, because we need not really control this. The neutral pin connection is done. So the my line pin of the main power supply, I would be giving it to the NO. additional small wire that I'll be using to connect from the relay. So here are the overall connections that I have made. The line wire goes to the first pin NC of the NO of the relay. So here are the overall connections that I have made. And in order to power up the ESP board, you can use any simple Android charger. So here is the main wire that I'm going to plug into the socket now. So I'm just trying to plug it in. So yeah, it's plugged in. So now you can look at this. The light is not at on. So now we will test that using our app. So here is the app. I have brought it up. So as we have seen, it has an on button. So when I click on this on button, it should turn on. So on, yeah, that's how it works. So it has an off button as well. So when I click on the off button, it should turn off the light. So that's how it works. Off, on, off, on, and off. So the next part of this project is to control the same thing using our voice commands. For this, I have used IFTTT as a bridge or the medium in order to interface between your home assistant and the app. So let's navigate to the IFTTT page. Um, After you go into that IFTTT website, you would first make an account. I have already done that, and then create two applets accordingly, and then tell it what to do when you request something. It's the way you would like it to respond when you say a certain phrase. So let's say when you say turn off my device, so what you would want it to do, you would describe that kind of stuff in here. So this is what it is. Mm, so this is for off request, and similarly I have the applet made for on request as well. So let me open it up. So that means you would fill up all the possible ways that you would instruct it to do some task. You can say either like turn on my device, or like turn on the device, or like turn on my light. It's all the possible ways that you would say something. And this is the phrase that you would want it to respond with. And this is the other part is to make the web request. This is the URL for that. I have used webhooks. um, Basically it can make or receive any web requests. This is where the URL part of this applet comes into picture, and this is my auth code and the value. So get method, and then content. So now we will go for the testing part of what we have done. So mm, for Android users, Home Assistant will be there by default, but for iOS uses, you have to install something called Google Home Assistant app. So I have already done that. I'll just start that app, and I would make the voice request. Hey Google, turn on my light.
Okay, Regender turning it on for you.
Oh, that's on. So then again, I'll request it to off it. Hey Google, turn off my light.
Okay, Regender turning it off for you.
Once again. Hey Google, turn on my light.
Okay, Regender turning it on for you.
That's good. Hey Google, turn off my light.
Okay, Regender turning it off for you.
Thank you. Now we have tested it through our phone. Let's test the same functionality using the Google Home device as well. This is my Google Home device. Let me plug this in and just powering it up. I think it's booting. It would take a while to come up. Yeah, I think it has come up. Now let's make the same voice request on the home device as well. Make sure my phone is off. Um, hey Google, turn on my light.
Okay, Regender turning it on for you.
Hey Google, turn off my light.
Okay, Regender turning it off for you.
Once again, hey Google, turn on my light.
Okay, Regender turning it on for you.
Hey Google, turn off my light.
Okay, Regender turning it off for you.
So now we have tested through the phone and the Google Home device as well. Let's also finally test through the headset as well to make sure the functionality is still intact. Before I go testing with this, I would remove this or plug out this Google Home device so that I can make sure that all my voice requests are just going through this one and not through the home device or through my phone. I'll turn on my headset. Okay, I don't know if you can really hear it, but I can still make some voice requests through the home assistant that's built into this. Hey Google, turn on my light.
Okay, Regender turning it on for you.
That's working. Again. Hey Google, turn off my light.
Okay, Regender turning it off for you.
It does the same response. Again, hey Google, turn on my device. Hey Google, turn off my device. These headphones are from Bose, and this is Bose Quiet Comfort 35 headphones, which has got a world-class noise cancellation feature, and it also has got a built-in Google Voice Assistant and Amazon Alexa as well. So that's the reason why this responds the same way like your other voice assistants do.